All right, I'm just going to give you a few heads up, not necessarily example problems, but just some quick refreshers. Don't forget with the directions given, a point on a terminal side when they're asking you to do that, they're really giving you, they'll give you like square root of 8 and 7. Don't forget, you're just drawing, they're both positive, so we're just drawing the triangle here, and we're doing the square root of 8, and we're doing 7, and then you're finding this side by a squared plus b squared equals c squared. And then what you find whatever they want from there. So you can do sine, cosine, secant, tangent, whatever the problem's asking you. So don't forget, when you're given a point and they want the terminal side, that's all they're asking you for. That's x, this is y. Your conversion rates, converting degrees to radians and radians to degrees. Don't forget, and opposite. Don't forget that you're doing pi over 180 or 180 over pi. Those are the things that we're using to convert from radians, from degrees to radians, use this one, and from radians to degrees, we use that one. Find exact value. Find exact value a couple different ways. Find the exact value of cosine of 7 pi over 6. Exact value, unit circle. Or your reference angle. Can't write. Reference angle. Trying to keep my hand out of the way and it's not working very well. Or your reference angle. So you have to figure out that it's on the unit circle or it's on the reference angle. So you're going to want to draw your triangle. 7 pi over 6 is over here. This is 7 pi over 6. Or it's 210 degrees. And then from there, you need a fraction. Don't forget, these answers are fractions. And then from there, you have to know your special right triangles. 180 degrees from 210 is 30 degrees. And then if they want cosine, it's root 3 over 2. That's an exact value. That's an exact value. Not a calculator version. That's an exact value. So you're going to have to either know the unit circle or you're going to have to use your reference angles. Oops. I hit that wrong. We've got a couple of different things here. Arc length. Arc length is your arc length is your radius times theta. So you need to have your radius. R is equal to radius. And your theta is equal to usually radians. So it's radius times radians. And that'll give you an answer. So you'll get answers like 7 pi over 2 or whatever you're going to come up with. So that's your arc length formula. Don't forget your function on the calculator when you're finding an angle. So if we're finding an angle here and they give you 6 and 11. This is my reference angle. This is opposite. This is hypotenuse. And so from there, it's going to be, since it's opposite over hypotenuse, it's the sine of theta. We'll call this theta, is equal to 6 over 11. How do I get rid of sine? I take the inverse sine of both sides. And use your calculator to finish that one off. Those cancel. Theta gives me some sort of a degree for the calculator. So don't forget those little pieces. The next one will have to do with factoring, doing all the different factoring techniques. And there's only a couple of factoring techniques that you need to worry about. And that's kind of where we're at. So that was just a quick little review. I'm not doing a bunch of example problems. It was just a quick review video about your basic trig stuff. You convert radians to degrees, finding the exact value. You got your arc length and your other pieces here, finding whatever you need, angles, sides, or anything like that. You also have extra videos and your notes. This is where taking good notes and doing what you needed to do in your class for the last couple of